Hello. Um, so, still working on that disk FIFO queue. It's going pretty well. There's not much to say about it. The only thing that's getting me a little bit like I don't know how to do it is that there's basically two memory queues, MQ1 and MQ2. Usually what I do is I call this the front queue and the back queue. And the read thread reads from the back queue. Actually, opposite way around, I think. So the read thread reads, or any read command is going to read, or the reader or whatever. Whenever you call read, it's going to read from the front queue. Whenever you call write, it'll append to the back queue, and that's just all memory. And then, so what happens is, let's say that the write queue gets too big, then we save it to disk. And then we start again. Another write queue. I think I explained this before. The complication arises during commit because the problem is like normally, this works fine. We keep writing and then we read, we just continue. So if there's like a bunch of files on disk of writes from beforehand, we just basically read and then delete it and write into memory and then add a new one, and it just kind of chases itself down in a loop. And that works fine until we commit, because when we commit, we have to store everything to disk. So let's say that we're partially done reading some file. Then, and then these are the rest of the files. Then when we write, then when we commit to disk, there's different options we can do. We could just kind of we get rid of this one and then write this kind of partial amount into the disk. The other option is that we could store let me just redraw it here, store the position we are inside the file. And this is important because we need to store the last commit before all working on the current commit. So, and we need to make sure we can always go back to the last commit. So if we have a last commit of like 1, 2, 3, and let's say we got partially done with the first file in our read, and then we're get commit called, we can't really get rid of this. So the only option we have is either to make like a temporary half file that's only used by this commit. And so it has like a different name. Like these files all get numbered, but this one would be like like a pre-read or something. That's one option. The other option, which I'm probably going to go for, is just to make it so the index, which is a separate file, which uses to basically atomically commit the commits, or atomically make sure that the commits are atomic. Right now it just has a start file and an end file. So in addition to that, I'm going to add also a start position, which will designate where it is in the first file. And so this way, in this upper scenario, where, let me just redraw it. So we have, say, 3 files, and our last commit was 1, 3, and maybe position 0. Then when we do another commit, let's say we got halfway through it, then our position might be 30,050, whatever the byte offset it is in this file, and then also 1, 3 for the next commit. So we haven't changed these guys. So when we're ready to move the index, it's a single move operation, and we don't have to worry about losing data. So that works. The only problem is that it means that when we read the data into the queue, we need to read first the objects themselves, v1, 2, 3, and 4, but we also have to read the amount of the length of the bytes that they take, or basically the position there in the file, because we won't know when commits can be called again. So as soon as it gets called, we need to know what the offset is here, so that we can put it up here, and I should say 2050, and put it up here to select the offset. So that's kind of what I'm thinking of doing. It's not, it's kind of weird that we're storing the length just for this weird one-off case, which won't happen very often, but the other option to create like a pre-file and stuff, it just seems more complicated. So yeah, and I'm close to done with the code. I just have to finish the commit function, and then after that I'll be done with the disk FIFO, which would be awesome, because then I can finally go to the rest of it. One other thing I wanted to say is, like, I'm not too familiar with Haskell's I/O, so I think part of the reason this is taking me so long is just because I have to learn how to do I/O in Haskell, and it's kind of complicated. And that's it.